Along this presentation, I will take you through the main research problem, the background of the study, the methodology, the results and discussion, and a short conclusion. Caireans face this exact scenario in their high, dense city, and the situation is worsened by both climate change and by Caireans having abandoned their older vernacular and traditional building practices that were intentionally designed to incorporate heat-reducing features. We selected Cairo, a dry, hot city in the global south where people live and work in. We monitored 4 urban typologies with temperature and humidity sensors during the 2015 summer peak in Cairo to evaluate which typologies could potentially reduce adverse impact on human health. We collected data in the 4 typologies in 4 different locations using air temperature and humidity measurements during the peak of summer heat between the 12th of July and the 22nd of August. One location is a high-density typology with limited urban green spaces and represents an informal settlement. In Cairo, 40% of the housing is informal. The medium-density typology represents a more typical middle-income housing location with a mix of roads, buildings, and urban green spaces. The low-density typology is representative of a high-income gated community, featuring 60% of urban green spaces with only 40% containing buildings and streets. The park typology was used in comparison with the 3 ones to scale how urban green spaces impact temperature and thermal comfort among the respondents. The rooms selected for the monitoring within the 3 building typologies, the high, the medium, and the low, were all living rooms. Construction materials used for the building envelope are similar in the 4 cases as it represents the typical building construction in Cairo. During the monitoring, we asked the occupants not to use any air conditioning to reduce bias in the results. Occupants' schedule, age, gender, and clothing were also accounted for in this study. These deltas were used as our indicator of heat stress based on empirical data collected in the 4 typologies. We calculated the mean change in coefficient for temperature and humidity indoors relative to the same type of data gathered outdoors. We considered effect estimates with a p-value below 0.05 to be statistically significant. We quantified climate change projections for outdoor heat stress in Cairo based on the IPCC RCP 6 medium range feature scenario from among 5 global climate models visualized within the climate chip analysis tool. This graph shows the measured indoor and outdoor temperatures in the 4 typologies. One can clearly see how the indoor environments buffered for the outdoor climate fluctuations. In all 4 typologies, air temperatures in both the outdoor and indoor environments retained largely above 30 degrees centigrade. These historical air temperatures measured on-site at Cairo Airport over a 20-year period from 1980 to 2020. It reveals an upward trend, namely a 0.51 degrees Celsius temperature rise each decade. Forecasts for future heat stresses in Cairo project further increases, even if using the modest mid-range future scenario model for the IPCC's RCP6. July outdoor temperatures in Cairo are already frequently above 35 degrees and are expected to rise higher under climate change. This is alarming given the thermal comfort between 18 to 26 degrees Celsius is a prerequisite for mental and physical health. To summarize our main results, the indoor environments buffered for the outdoor climate fluctuations. In all 4 typologies, air temperatures largely remained above 30 degrees, risking persistent heat stresses day and night for residents. We observed slightly higher indoor temperatures relative to the outdoor temperatures in both the high and medium density typologies. We would like to note that the relative humidity observed differences are within the error margin of the measured device used. The low density typology had indoor temperature readings that were cooler than outdoor temperatures. Respondents also experienced a reduced feeling of heat. Relative humidity observations in all 4 typologies were slightly lower indoors than outdoors. Climate change has already caused an increase in heat exposures in Cairo, and this trend will continue. Our study revealed two main issues for discussion, one connected to the high density typology and one connected to the low density typology. The cons for the high density typology that there is lack of green urban spaces, worsening urban heat island effect. Poor building envelopes retain heat, inefficient ventilation requiring high reliance on mechanical air conditioners. While the pros from high density typology that this clustering of buildings with high dense cast shadow that reduce indoor heat gains via facades and could also shade pedestrians. Better window to wall ratio can reduce heat gains from building wall glazing. And when it comes to the low density typology, we can see the cons that the huge horizontal surfaces revealed abundant asphalt and concrete surfaces. The vertical surfaces for the building increased glazed facade exposed to direct sunlight and of course increase day heat gains. And the low density typology, we can see the pros in the more urban green spaces, which is equivalent to low cost design strategies to lower indoor temperature. Also, the trees around buildings provide shade on building facades, sidewalks, and also streets. Good ventilation from air moving between homes like Korean courtyard design enhance the outdoor air temperature. Thanks for tuning in, and for further questions, please do not hesitate to drop us an email. Thank you so much.